You know, it's pretty wild when you think about it. Every single element in our bodies, the stuff that makes up our phones, our cars, our world, it was all forged inside a star. Stars are the ultimate givers of life, these cosmic factories that literally build the universe as we know it. But there are also these incredibly violent, unpredictable engines of destruction. We're living in this super delicate balance, right? Thriving thanks to the very same cosmic forces that could just wipe us out. So let's dive into that duality, the star as both our creator and maybe our destroyer.
I bet a lot of you saw this. Back in May 2024, the sky just lit up with these incredible auroras, visible way further south than usual. It was beautiful, right? A massive G5 geomagnetic storm that absolutely took over social media. But that amazing light show, it was also a serious reminder of the raw power our sun can unleash. And for our tech-heavy world, that kind of power is basically a warning shot.
To really get our heads around this relationship we have with our star, we've got to go back. I mean, way back. All the way to the beginning of time, right after the Big Bang, when the very first stars flickered to life in a universe that was pretty much just hydrogen and helium.
So, scientists have a name for these theoretical first stars, population 3. And you gotta understand, these weren't anything like the stars we see in our sky tonight. Nope, they were a totally different breed, born out of a clean, simple, primordial universe. These were the true pioneers of the cosmos.
The size of these things is just hard to even imagine. Try to picture a star 1,000 times more massive than our own sun. They burned incredibly bright and lived fast, dying after only a couple million years in these spectacular explosions called supernova. But that violent death, that was their real gift to the universe. It was in those final moments that they forged carbon, oxygen, iron, all the heavier stuff that makes up, well, you, me, this planet, everything. We are, and this is literal, made from the ashes of these first stars.
But it turns out, this cosmic inheritance wasn't just a jumble of raw elements. The whole process of making stars and planets creates something way more interesting. And now, thanks to some amazing new tech, we're actually finding the receipts, the literal building blocks of life, frozen out there in deep space.
With the unbelievable power of the James Webb Space Telescope, astronomers took a look at a stellar nursery in a nearby galaxy called the Large Magellanic Cloud, and they focused on this one little baby star, a protostar they call ST6, which is still all wrapped up in its original cocoon of gas and dust.
And what they found, frozen onto tiny dust grains around this young star, was just incredible. Complex organic molecules. We're talking about things like acetic acid, yep, the main ingredient in vinegar, and different kinds of alcohols. But here's the most important part. They found the chemical precursors, the fundamental ingredients you need to start building even more complex things, like amino acids and RNA. You know, the very foundation of life as we know it. So, this amazing process of creation, of forging elements and complex molecules, is all driven by this immense energy. But that energy, well, it has a dark side. So what happens when that same creative fire that builds worlds gets pointed directly at one? Let's bring it back home and take a look at the star right in our own backyard.
Okay, so our sun basically has two main ways of throwing a fit: solar flares and coronal mass ejections, or CMEs. It's really important to know the difference. Think of a flare like the bright flash from a cannon. It's a burst of radiation that gets to us at the speed of light in about 8 minutes. A CME, on the other hand, that's the cannonball. It's the sun physically launching a billion-ton cloud of plasma into space. It's slower, yeah, but it packs a way bigger punch when it slams into our planet's magnetic field.
And these events aren't just some abstract science concept. They have very real, very tangible effects on our ambitions in space. And sometimes those effects are just deeply ironic, as one recent NASA mission found out the hard way.
Just picture the scene at Mission Control. It's early November 2025, and this superactive sunspot starts going crazy, firing off CMEs toward Earth. Then, on November 11th, it unleashes a monster X5.1 class flare, the biggest of the year. This triggers a powerful G4 storm right when NASA and Blue Origin are on the launch pad ready to go with the Escapade mission. They had absolutely no choice but to scrub the launch and wait for that solar hurricane to blow over.
I mean, the official statement really says it all. A brand new spacecraft with all its sensitive electronics is at its absolute most vulnerable during launch and deployment. Trying to fly through a severe geomagnetic storm was just a risk they could not take.
And here's the kicker. The entire reason for the ESCAPADE mission is to go to Mars and study how that planet lost its atmosphere because of these exact same kinds of solar storms billions of years ago. A mission designed to study the destructive history of space weather got delayed by the destructive power of space weather today. I mean, you couldn't make this stuff up.
This whole incident just goes to show how critical it is for us to be able to predict these solar outbursts. So how do scientists actually do it? How do they forecast the sun's fury and read its secret language?
Well, one of the key tools they use is a system called the Macintosh sunspot classification. See, forecasters don't just count the sunspots. They categorize them, almost like criminal profiling. They look at their size, their shape, and, most importantly, how tangled and complex their magnetic fields are. The more complex the group, the higher the chance of a big flare.
Now, I want you to look at this number, 8%. Doesn't seem like much, does it? Just 8% of all the sunspot groups out there.
Okay, now what about this one? 48%. That's nearly half of everything. So how on earth are these two numbers related?
Well, the connection is absolutely staggering. That tiny 8%, the most magnetically complex sunspot groups, are responsible for almost half of all major solar flares. It's like the 80-20 rule, but for solar explosions. This lets forecasters cut through the noise and focus on the very small number of sunspots that pose a real, serious threat.
But here's where the sun's dual nature gets even weirder. While a solar storm is obviously dangerous if you're in its path, it also acts like a temporary shield for the whole inner solar system. That massive cloud from a CME literally sweeps through space, pushing away even more dangerous particles called galactic cosmic rays that come from outside our solar system. So for astronauts on the space station, a solar storm can, counterintuitively, lower their overall radiation exposure for a little while. This whole complex dance between risk and protection is absolutely central to our future in space. As we start planning to go back to the moon and then on to Mars, learning to live with our volatile star isn't just a good idea, it's a matter of pure survival.
Even when the sun is quiet, space is not a friendly place. Our own planet is surrounded by the Van Allen belts, these giant donut-shaped zones of intense, trapped radiation. Any satellite, any person passing through them gets zapped with a heavy dose. They are a constant, invisible hazard we have to plan for.
And once we leave Earth's protective magnetic bubble, the stakes get so much higher. For astronauts on a 9-month trip to Mars, a surprise solar storm isn't just a risk to the mission, it's potentially a fatal event. We're talking a lethal dose of radiation delivered in a matter of hours. That's exactly why any future base on the Moon or Mars will have to have a storm shelter, a heavily shielded safe room where the crew can hide out and wait for the storm to pass.
And that brings us right back to where we started. The very same stellar forces that created the elements in our own bodies are now a major threat to the technology we've built to reach for those stars. The fundamental challenge for our future in space, really, is learning how to respect, predict, and ultimately survive the fire of our own creator.